Okay, the session is being recorded right now. Well, good morning. My name is Ivan Grachev. I'm your convener and I'm also your instructor. So today we're going to have our first tutorial. Each week we're going to have a tutorial. Before, what we did is our lecture was on Tuesday, and usually lecture relates to the tutorial. So what we talk about in lecture, then in tutorial we'll just talk a little bit more and do some more exercise. Unfortunately, this year we have this tutorial, which is a little bit, well, it's a bit earlier than before compared to the lecture. So lecture will be on Wednesday. I mean, it's today. And we'll talk about soil constituents. And we're going to have tutorial that actually covers some of the material that I was planning to talk about this afternoon. Hopefully you guys watch some of those pre-recordings that I made last week about soil constituents. And there was also a few exercises that I explained how to do in those videos. If I think it's better, especially for you who attend this tutorial, it's better if you watch recordings for like next week. I mean, for like lecture that week in advance, so that you will have a little bit of better understanding of what we're going to talk about. Well, again, I'll explain things, and I'll explain, show you how we solve these problems. But I think if you can just kind of sort of look at the material that we will talk about today, like on that day in the afternoon, that would be good. So we'll start with soil constituents, and this is the first one. Let me use my pen. So soil constituents, and I will briefly give you some theory, what soil constituent means, and three phases in soil. When we collect soil sample, like something like this, you will see that when we just look at the sample, you will notice that the soil sample is made of like what we call like three different phases. So it's made of soil grains or particles, and this is something that we call S. Then these soil particles will create a matrix. And inside this matrix, you will see empty space, what we call voids. So in this case, I'll change the color to, so we have voids here. So everything between the soil grains will create voids. And voids can be filled with water, and or if there is like nothing there, just maybe air bubbles. Even in water there can be some trapped air bubbles. So voids can be empty or they can be filled with water. So we have three phases: solids, water, and air. And what we're going to do next is just we're going to simplify this soil structure, and we'll only look at the like substances. So we look at so we have certain amount of solids, we have certain amount of water, and we have also air in that pore space. So next step is we will look at two major things. We'll look at the volume of each phase, and we're going to look at the mass. And when we look at the volume, we're going to say that volume of solids will be equal Vs, volume of water will be VW, and volume of air VA. Same thing we can do about mass. So we can measure solids, and we'll say this is mass of solids, MS. This is going to be mass of water. This is mass of air, but we know that mass of air is 0, so it's 0 here. So when we also look at the void space, we know that solids will create a void space in the soil. So then water of volume of water and volume of air, it will make up the total volume of voids. because voids are filled either with water or air. So if we don't have air, only water, so in this case, soil is fully saturated. If we have no water, we have only air, so in this case, soil is dry. So now we're going to use this volume and mass to create some definitions and some ratios to describe soil properties. So the one that we're going to use in this tutorial and the one that is very important to describe the soil property in the field, it's first it's void ratio. So for void ratio, it just shows you how much voids in the soil. So what we do is we use volume of voids and divide by volume of solids. So if we have lots of voids, like we have a clay, so in this case, void ratio will be very high. And when I talk about high, it will be from like 1 to 2 values. So void ratio has no units because you take volume and divide by the volume. So for sandy material, usually there is a larger volume of solids compared to volume of voids. So usually, in this case, void ratio of sand, it's like less than 1. So maybe from 0.5 to 0.7, 0.8, this kind of ranges. Okay, so another one that we're going to use today, it's also degree of saturation. And we use it S. So degree of saturation shows you how much water is in the voids. So we use volume of water and divide by the total volume of voids. So this is two important values related to volume that we use to describe the soil properties, like the way soil is in the field in nature. Now, if we look at the mass ratios, masses. So again, one of the important thing is related to mass. It's density, and density, you should probably know this from high school or from like just like general knowledge. It's mass of soil divided by volume of soil. So mass of total soil divided by the total volume of soil. If we have dry density, we also use this one. We call it dry. So in this case, we're going to use mass of dry soil and divide it still by the total volume. So you will see that density, like in general density, what we also call bulk density or moist density, usually is higher than dry density. Because here you have like mass of solids plus mass of water. In this case, you have only mass of dry soil, which is equal to mass of solids, and you don't have mass of water. So dry density is always less than just like normal density, bulk density. And another important thing that we need to know before we start solving these problems, it's water content. So water content, we use W. So it again shows you how much water is in the soil. In this, like for volumes, we use a degree of saturation, but for water content, we use mass of water and divide by the mass of solids. Oh, this is very bad, M. Mass of solids. So S means solids, not soil. Mass of water and mass of solids. For some soil like clay, you'll be surprised, but there is more water than solids in such material. So water content can be actually higher than 100%. So we very often we use percentage. So multiply by 100%. So these are important things that we need to know. There's, I guess, few more. I will show you a few more when I go to the next slide. You see, this is like same three-phase diagram, special case. Maybe you will still like don't need to know this one yet. So you will see that this is value G with a small case s. This means a specific gravity. So specific gravity, again, I'll talk a little bit more during the lecture about it, but just want to give you the definition. It shows you how heavy solid particles are compared to water. So it's density of solids to density of water. A very common mistake that students make, they think that density of solids it's density of dry soil. That's wrong. So density of solids is always higher than density of dry soil. So I'll explain this because this is really a common mistake. Density of solids, it's not very easy to write on the screen. Density of solids, it's mass of solids divided by volume of solids. This just comes from the definition of density, right? It's mass divided by volume. So dry density, it's mass of solids, mass of dry soil divided by total volume. So as I already mentioned before, mass of solids and mass of dry soil is same thing. Mass of solids equal to mass of dry soil. Because dry soil has only solids. It has no water because water was removed by drying the soil. And well, it does have some air, but air has no mass. But you see the difference is here. For dry soil, we have total volume, which is will be this one is total volume. This is total volume, VT. So what we do, we take this mass of solids and divide by this value, which is very large volume. But for density of solids, we use only this value, which is volume of solids. So that's the difference. So mass is the same, but volume is different. That's why density of solids is always higher than density of dry soil. Density of solids here, it's usually in the range from 2.4 to 2.6. When we talk about dry density, it's usually in the range from like around 1, maybe 1.2 grams per cubic centimeters. It's also grams per cubic centimeters. Okay, that's for density and specific gravity. Okay, well, I tried to explain it to kind of like briefly talking about the major things, major definitions. Well, I hope you guys understand these kind of things. And again, we're gonna go through the examples and I will explain how it works. Okay. Well, if you have questions, please write your questions in the chat box. I'll take it as no questions. Okay, there are 3 problems in this tutorial. I'm going to spend lots of time on the first problem because like other problems are pretty similar. And the first problem is the one that will actually, when we do this problem, we can also look at these definitions, the way that we use them to solve these problems. I'm just looking at this one and it's incorrect for some. It should be unit weights. It should become I don't know. It's probably when you convert this PowerPoint to PDF, like it makes some mistakes. Yeah, and actually, it reminds me that I haven't explained the unit weight of soil. So I'll explain it now, and then we'll do this problem. So I already talked about density, right? And something that you really know, density. And for soil, it's usually 1.5 to 1.8 grams per cubic centimeters. This would be like a good range for most of soils. If you get something strange, like something much higher, this means that you made a mistake and there is something wrong. So density, like we use it in science very often, but in soil mechanics, we're not going to use density. We're going to use unit weight. And the definition of unit weight is we take weight of soil and divide by the volume. So it's kind of similar to density. Density, it's mass divided by volume. So why we're going to use unit weight? Why it's more important than density? It's because when we calculate stresses that act in soil mass, we need to know the unit weight. So what we're going to do, if we get density, value of density, we'll just change it to unit weight. So unit weight will be always our preferable value in soil mechanics. So the way to do it, to get unit weight, either we use weight of soil and divide by the volume, or if we know density, that unit weight it's density divided by the gravitational acceleration, which we're going to use 9.81. So the formula will be density times 9.81. Unit weight, if we use density in, let's say, grams per cubic centimeters or tons per cubic meters, or megagrams per cubic meters, it's still going to be, in terms of the number, it's going to be still same number. It's going to be like 1.5 grams per cubic centimeters, or 1.5 tons per cubic meters, or 1.5 megagrams per cubic meters. So if we use these units, we just multiply by 9.81, and then the unit weight that we're going to obtain will be in kilonewtons per cubic meters. Kilonewtons. And so this is the way that we do it in soil mechanics. Just make sure you don't make any mistake with these numbers and conversion factors and the units. Again, we will do like lots of things like that, and maybe now you feel a little bit like, I don't know, like not sure about it, but once we start calculating the unit weights, you will see that it's pretty easy if you know density. Just multiply by 9.81. Okay, so I'll remove this one and again change to unit weights. Okay, so what we're going to do with this problem is we have some soil sample, undisturbed soil sample, and we know the volume. Volume of the sample is 0.0125 cubic meters. And we also know water content. Water content is 21%. We use percentage, but we can also use ratio, 0.21 ratio. And total weight, it's 0.12 kilonewtons. Also, like in our daily life, we use weights, which means mass. We just say like, what's your weight, right? Like let's say like 70 kilos. But like what we actually ask, we just ask for mass, because mass, that's what we measure in kilograms, and weight, it's a force, and we use newtons, to measure weight. Just like remember that. Well, I'm sure you know that. It's just like to remind you. So weight is the force, and we use newtons. And we need to find all this weight of solids, unit weight of soil, dry unit weight of soil, degree of saturation, void duration, and porosity. So what we will do next is we will start going through the definitions, and we will start finding each of these things that we need to find. And the first thing that we would start with is just we have total weight, and total weight is equal to weight of solids plus weight of water and plus weight of air. This is the same thing. Well, remember in that three phases diagram, I talked mass, and then total mass, it's mass of solids plus mass of water and plus mass of air. We can do the same thing for weight. So in this case, we can say that weight is equal weight, total weight, which is equal to 0.25. It's equal to weight of solids plus weight of water and plus weight of air. We know that air has no mass, so it has zero weight. And then what we're going to have is 0.25. It's equal weight of solids plus weight of water. Okay, so we have weights of solids and weight of water. What other variable like ratio we can probably use to link them together? Do you remember I tried to like show it in the first slide? I mean, explain. So like sort of mass of water and mass of solids. Anybody remembers? If you can remember, just can you write what value of soil we can use it? We use that actually has also mass of solids and mass of water in its definition. Density, mass of water, mass of no density. Density has mass, but it also has volume. Just only mass of water and okay, yeah, okay, I see, yeah, water content, yeah, that's correct, yeah, that's correct. So density will be a little bit different, but water content, yes. So remember that water content, it's if we change to, well, I showed you the definition using mass, but it's the same thing for weights. Weight of water divided by weights of solids. And we know that the water content, it's already 0.21. So it's 21%, but I change it to ratio. So I can write this equation here that weight of water divided by weight of solids, it's equal 0.21. So we have two unknowns and we have two equations that we can solve. So we can, for example, replace weight of solids with weight of water and just solve it against weight of water. And I'm sure that you are really, you know how to do it. You are really capable of doing this. So that's why I'm going to next slides. So this is what we did. Step number 1. You guys answered correctly. Yes. Water content is weight of water divided by weight of solids. And we also know that total weight is equal weight of solids plus weight of water. We're going to solve this equation, and we would just replace weight of water with weight of solids, and we're going to find that weight of solids, it's this much. Okay, well, this is kind of like simple math. Well, I'm not sure how simple it's to you, but this is something that I guess you should probably know and like know how to do it. So I'm not going to talk about this kind of like mathematical procedures. I'll talk about some mechanics things. And then once we know weight of solids and we know the total weight, we can find weight of water. Right? So weight of water will be total weight, which is 0.25 minus weight of solids that we just found, this one, and it's going to give us 0.043. Okay, so let's go to the next step. Okay, so next step, once we know weight of water, we're going to find also a volume of water. We need to know volume of water because we can find degree of saturation. It's volume of water divided by volume of voids. Also, if we know volume of water, we can also find volume of air because total volume it's volume of water plus volume of solids plus volume of air. So air has also volume. It has no mass, but it has volume, so we need to find this one. So we need volume of water here, water volume here. And the way that we find it is we use the definition of density. Density is mass divided by volume. If we use definition of unit weight, we just replace mass with weight divided by volume. So in this case, volume of water will be weight of water divided by unit weight of water. Okay, how to find a unit weight of water? What is going to be the unit weight of water? Anybody can write it in the chat? The number of unit weight of water. This is something that you should remember. So it's density times 9.81. I showed you before the definition of unit weight. It's density times 9.81. 9.81 comes from the gravitational acceleration value. What is the density of water? Anybody knows the density of water in grams per cubic? Yeah, it's 1,000 kilograms per cubic meters. That's correct. What we're going to do, we just use grams per cubic centimeters. It will be 1. So it's same thing. It's good that somebody knows that we have also kilograms per cubic meters. It's same thing as 1 gram per cubic centimeters. So what we're going to do now is if we use density in grams per cubic centimeters, 1, we just multiply by 9.81 and going to get our answer in kilonewtons per cubic meters. If we use 1,000 as a density, we also multiply by 9.81, but then we're going to get our answer in newtons per cubic meters. So it just, if we change to kilonewtons, we just remove 1,000. So you can do it either way. So if you put like 1,000 here times 9.81, you're going to have answer in 9.810, which is newtons per cubic meters. We still prefer in storm mechanics, we prefer to use kilonewtons. So it's going to be 9.81 kilonewtons because if it's 9,810 newtons. So in this case, unit weight of water will be 9.81 kilonewtons per cubic meters. So this is something that you should remember. This is something that we know and it doesn't change. So 9.81 kilonewtons per cubic meters. That's why we have, should be 1 here, 9.81. And this is going to give us volume of water. Here, here. Okay. So How can we now find volume of solids? What do you think, guys? How would you approach this volume of solids thing? What kind of correlation, relation, or formula would you use? Anybody has idea how we can, for volume of water, we use weight of water and density of water. How can we find the volume of solids? Because we need volume of solids to find the void ratio, to find volume of air. So this one. Remember that void ratio is volume of water divided by volume of solids. So we still need volume of solids. Volume of solids here. How do we find it? Anybody has idea? Mass divided by density. Yes, that's correct. So you will see that maybe at first you'll be intimidated by all these like ratios, formulas. But if you look at the procedures that we use to solve these problems, they're very similar. So usually we use density, mass, and volume, or like unit weight, and volume to find whatever we need to find. And we're gonna have the same thing. So it's gonna be the same approach. We're gonna find a volume of solids through the weight of solids and density of solids. Correct? Do we know weight of solids? We do, right? We found it here. So how do we find then density of solids or unit weight of solids? What do you think? Just density of solids. Because with density of water or unit weight of water, it's easy. We just know that we already know density of water. It never changes. But density of soil, density of solids, it will change. It's not like, unfortunately, it's not just like one value. Density of solids depends on the type of minerals in the soil. It can be quartz, calcite, or feldspar. So it always has a different density. So we know the weight, just need to, or like mass of solids, just need to find the volume. And to find the volume, I will show you there is another thing, another ratio that I explained to you. It's specific gravity. Well, we don't really worry, like in this course, we don't worry about temperature for water density. I think we do need to kind of like make a statement that it's at like certain temperature, that the density it's 1 grams per cubic centimeters per thousand, but it's not the kind of like science type of problems that we have here. And we typically assume that like density of water, it's like same that like for the range of temperatures that we use in soil mechanics. So we just don't worry about that. Okay, so the thing that we're going to use for density of solids is specific gravity. It's density of solids divided by density of water. So from here, we will see that density of solids will be equal specific gravity times density of water. And we can still change it to unit weight. So it's something unit weight of solids. It's specific gravity times unit weight of water. This is something that we're going to use to find the unit weight of solids. And next slide will show it how it works. So this is going to be the formula. So this value is unit weight of solids. It's written through a unit weight of water. And we already know unit weight of solids, it's 0.207. Yeah, there's a formula sheet, yeah. So there is a formula sheet for all these definitions and ratios, and I will show you like where to find it. So, and second problem, and even third problem that I will show you, we just use the formula sheets. So when you work on your projects, or like quizzes, you can use either definitions or you can use formulas. So I think students prefer formulas because it's a little bit faster and easier. But for you to understand the definitions, I would do like this first example and spend more time to show like the definitions and the ratios and get it. Okay, great. Okay, so we'll find a volume of solids. Sorry. And next we'll find volume of air, which is total volume minus volume of water and volume of solids. We're going to get volume of air. And I think we have everything to... yeah, this is kind of like a summary slide where we are given volumes for each component. And sorry, and we have weight of solids and weight of water. Okay, can you look at this slide and tell me what is going to be volume of voids? Volume of voids. Just type in the number. No, 0.0045. Yeah, that's correct. Volume, maybe like there is no mass of voids, yes, but volume, there is always volume. So remember that volume of voids, I'm going to write it here. It's volume of air plus volume, volume of water. So in this case, we're going to have a volume of air 0.0001 plus 0.0044, 0.0045. And we use cubic meters, right? Okay, so can you tell me how we can find our void ratio? Remember, it's the ratio. So what do I need to write here on the top? What number I write? Volume of voids, and yeah, it's 0.0045. And volume of solids is going to be 0.008. And that gives us, let me check my notes, how much is going to be void ratio. It will be 0.5625. Okay, with yeah, very good. 0.5625. Somebody is very good at calculating things. So when you present results, just for the future, and also if you don't wanna drop any points in your projects, so usually for void ratio we have decimal numbers. So in this case we can round to 0.563. So that will be the answer that I will have for void ratio when we present the results. Another important thing is we don't use percentage. So some students try to change it to percentage, 5.6.3%. That's wrong. So never do this one because that's going to be a mistake. So void ratio is always in ratio. Water content, yes, you can change to percentage. Degree of saturation, yes, you can change to percentage, but you don't like change void ratio to percentage. Okay. What about degree of saturation? That's one of the things that we need to find. What are the numbers right here? Anybody can give me the numbers? So degree of saturation shows how much water is in the voids. So we'll look at the volume of water, right? Yes, it's going to be 0.0044. And we divide by 0.0045. Is it correct? Mm-hmm. Degree of saturation we can also change to percentage. And yeah, ratio is gonna be 0.978. Or if we change to percentage, 97.8%. What do you think about this degree of saturation? Like, if you just look at the data, what would you like say about the soil if it has degree of saturation like 97.8, almost 100%? Is it good or bad? Bad. Yeah, it's bad. Yeah. Why do you think it's bad? It's correct. It's bad. Yeah. It just shows that that soil is almost saturated, which means that all the pore space in the soil like filled with water, and water makes soil weaker. So if you see a very high level of saturation, it means that soil may be like not good foundation. So we just need to like drain water from the soil, like dry it up somehow to make it like stable, like better foundation than when it's wet. So degree of saturation shows you this idea. I mean, gives you this idea. Okay, so I think we kind of look at major characteristics of the soil. Let me see what is left. We did void ratio. We did. Okay, we didn't do like bulk unit weights or just moisture unit weight. It's same to density, but we use weights divided by volume, and this is something that we could have done before. Dry unit weights, we use weight of solids and still divide by the total volume, and we get this much. So you will see that weight or like bulk unit weight or moist unit weight is always higher than dry unit weight, because here we have also additional weight of water. That's why it makes it a little bit higher compared to dry unit weight. We did degree of saturation, good. Porosity, it's another thing. It's not very common for soil, but it's very common for rock, because rocks usually don't have much like space. So in this case, we use volume of voids, and we divide by total volume and use percentage 36. Okay, so let me see if there is anything else. Problem 2. Before I go to problem 2, let me show you where you can find formula sheet. I'm going to what is it? Or you already know where to find formula sheet. I can go back to the slides. Yes, this one. I'll also post the slides. I will post them on, I think, like tomorrow, because we have another tutorial tomorrow, which is same. I will just post this slides, just PDF slides. You can look at them. Or also it's recorded, so you can always play it back. Let me briefly, quickly show you. Share. Yeah, labs are also recorded, so I record everything. I'm not sure if I can record everything, but I still do record everything. Look, so if you go to, well, first of all, you can find all notes here on this summary. So formula part 1, so all the, you see specific gravity, density, void ratio, all here. Also definitions all here. This is what we're going to use later to classify soil. This is part 2, when we already start talking about water, stresses, water flow, and shear strength and consolidation. So this is already for like second part of the course, I think from week 6 or 7. What you need to use now is these first 2 pages. Another thing, if you go to So constituents, today's lecture. There is some videos that you can, and lecture notes. Exercise that we're going to do is also recorded, and this is useful formulas. So this is just first part, first 2 pages. Typically, I would print it out and give it to students when we have face-to-face lectures. So all the, you see, formulas, density, saturated, degree of saturation, relative density is all here. So you can just download from there. Okay, so I'm going to go to next question. We don't have much time left, but the good thing, I explained to you guys how it works. Maybe relative density will just not show it to you. I will show it in the lecture. I want to show you problem 3. So in this case, I will show you how to use formulas. So again, you can go through the ratios. That's okay. But formulas, like students for some reason find it like easy and probably faster, so they prefer formulas. Kind of similar type of question. We have soil, and in this case, you see, if you find this word saturated, this already means that degree of saturation is 100%, or it's 1. So you will need to know this value, because there are some formulas they use degree of saturation, and we actually like need to know this one. So you see, I don't say that this soil has degree of saturation 100%, but I say soil is saturated, which means you should know this one. This is very common in quizzes, in all the questions that I'm going to ask you. I'm not going to tell you the degree of saturation, but I will tell you that the soil is saturated. In this case, degree of saturation is 1. So it has mass of 651 grams, and it has volume this much, and it was dry up in the oven, and when it was dry, so it got a mass of 416. So what we can say that mass, like total mass, was 651 grams. Then dry mass was 416 grams, and volume was 390 cubic centimeters. We need to find specific gravity. So I will explain to you how we do this. We have a few more minutes, and then we will just, I will show you slides with the solutions. First of all, what we can find is we can find water content and then dry density. So water content is mass of water divided by mass of solids. So mass of water is the difference between total mass and mass of dry soil. And then mass of solids, it's same thing as mass of dry soil. So we can get that 651 minus 416 divided by 416. And this will give us 0.565. Or if we change the percentage, 56.5% water content, pretty high. Another thing that we can find is we can find dry density. Dry density, it's mass of dry soil divided by total volume. So in this case, mass of dry density, it's 416 divided by volume is 390, will give us 1.06. 0.067 grams per cubic centimeters. Okay, so this is the numbers that we have, and then I'll just and also what we know is degree of saturation is equal to 1. And another important formula that is given in the formula sheet that you can use, it's links water content with degree of saturation, void ratio, and specific gravity. So this is formula used very commonly. So in many problems that you may probably deal with in this course, at some point you may use this formula because it relates water content with degree of saturation and void ratio. We know that degree of saturation is equal to 1, and water content is 0.565. So in this case, we can say that we're going to write it here. So we can say that void ratio is equal 0.565 times specific gravity. Okay, so and this is something that we're going to use. I'm going to next slide. I'm not sure what is happening with the PDF because I have a PowerPoint presentation. I changed to PDF. Maybe next time I should use just PDF slides, not change it. So the formula that we are going to use is also given to you in the formula sheet. It's dry density, specific gravity times density of water, 1 plus void ratio, and like this, right? Let me check the formula. Density, yeah, that's correct. I just look at the formula sheet, and that's correct formula. And what we will do now is we'll just, we know that dry density is 1.067. We know that density of water is 1 grams per cubic centimeters. And we know that void ratio is equal to 0.565 times specific gravity. So in the end, we're going to get 1.067 equal to specific gravity times 1 plus 0.565 times specific gravity. So you have only one unknown, and from solving this problem, you're going to get the specific gravity. It's equal to 2.69. Remember that specific gravity has no units. It's because specific gravity is the ratio between density of solids to density of water, and this is what you get, 2.69. You have any questions? It just it's already about time. I spoke for like few extra minutes, but the good thing we talk about this first problem and we look at the ratios, and also I showed you how we can use formulas. There's things that we're going to do today in the lecture. Yeah, so I'm just reading questions that we do, the tutorial questions and problems for practice for each topic we cover every week. Yeah, I think it's, if you can just look at the well, these problems that we do, they're related to the also lectures, and also these problems how to find this unit weight, specific gravity. This all be also covered in your first project. So the first project, your big assessment item, You'll be given volumes, you'll be given masses of soil. You should be able to find what is necessary, like density, unit weight. If you can, we will do a few more exercises today in the in the lecture, and I already posted a few of those exercise problems online on YouTube, so you can always look at that. If you can look through the questions, that would be good. I will also upload the solutions, the slides that I showed to you. I think tomorrow in the afternoon or Friday, so that you can look at them as well. Any more questions? Well, if no more questions, I assume that you may be probably hungry, and it looks like already like lunchtime. Well, thanks everybody for joining the session. It's recorded. You want to play it back. I have another tutorial like this tomorrow. If you have questions, just join. Thanks everybody for your time, and have a nice day. Yeah, everybody has a nice day.